Yay, thank you guys so much for coming. We have fixed the technical difficulties, so finally we can start. Tell me if you can't hear me at any point, or if I speak too fast, you can raise your hand or something, because sometimes I do that. Okay, awesome. So on the slides, we can see the portal code and the link for the slides. The portal code is string arrays because we're working on strings and arrays. Should be fun. So I'm going to give you like 60 seconds to pull this stuff up if you want to. You can tell. Okay. Awesome. I guess we'll start now. So I'm just going to switch it past the next slide. Okay, yay. So we're going to start with what is an array. I mean, a lot of the people who are here probably already know what an array is. So this is probably going to be more of a review thing. But either way, this is beginner's check. So we're going to go over it from the very start. Cool. So in C++, an array is a data structure. Okay. In C++, an array is a data structure that holds elements of the same data type. In arrays, elements are stored contiguously or next to each other in memory. So you can see we have like an array of integers, an array of booleans, an array of characters, but that isn't like, what is that? It's not an array, unfortunately. Awesome. So to declare an array in C++, you can use the following syntax: data type, then the array name, within brackets the number of elements, and then with the curly brackets, you can list off the elements that you want. So for example, you could do, you want an array of integers called ages with 5 of them, and you have these numbers in there. Cool. Alrighty. And then to access elements in an array, you use the following syntax: the name of the array with the brackets, and then the number of the element that you want to access. And it's important to know that in C++, arrays are 0 indexed. This means that the first element in the array is actually the 0th element, and then the other numbers follow suit. So you can see here how there are 5 elements in the array, but the last element there is not the 5th element, it's the 4th element, and the first one is the 0th element. Alrighty. And you may not know what you want the elements to be when you're declaring the array. So in that case, you can leave off the initialization list, the like curly brackets with the elements in them, and you can instead put, you can use like a loop to fill it up later. But in the meantime, your array will be undefined. So do not access it, or try to modify it because it does not have any elements in there. All right. Cool. And so I also want to introduce to you 2D array. Again, I'm assuming you know this, so this will probably be reviewed. But 2D arrays are also often used in competitive programming. For example, if you need to simulate a game board, store a graph, or otherwise deal with data that varies on 2 different parameters. And in this case, each element is referred to by 2 indices. The first index refers to the row, and the second to the column. You can see right there, we have 0, 0. We have 1, 3, and 2, 4. Row, column. Alrighty. And you can initialize and work with 2D arrays using very similar syntax to what you'd use for 1D arrays. You simply add a value in brackets to represent the second dimension. So here's an example. I'm going over this very quickly because we won't be using 2D arrays today, but later in your competitive programming journey, you will definitely use them if you haven't used them already. So just want to introduce them to you. Awesome. So what if when you're creating your array, you don't know what size you want your array to be? You may notice that to declare an array, you need to first declare a size. What if you want an array that could resize itself based on the amount of elements that you have during runtime? If that's the case for you, you will love vectors. A vector is essentially an array that you don't need to know the size of when you create it. So in many ways, it's easier to use an array, but it might look complicated if you haven't used vectors before. I know when I hadn't used vectors before, I did not use vectors for a while. I kind of still use arrays, but not because vectors are hard, just because you can kind of pick and choose. Some people prefer vectors, some people prefer arrays. Either way, we're going to teach vectors. So if you want to use a vector, you have to use this include statement at the top. If you're using the hashtag include bits C++ thing that we will get that back up. Sorry about that. Thanks, Robert. If you're using the bits C++.h whatever header file that we introduced on the first day 2 weeks ago, then you will. Can I stop briefly while we? Yeah. Okay. Well, hopefully you can have this open on your computer so you can follow along in case this goes out again, because it might. Okay. If you use the bit/std whatever, then you won't need to include this vector statement right here. But because vector is not a primitive data type in C++, meaning it's not like built into C++ like arrays are. So just know that already. And to declare a vector in C++, you can use the following syntax. So vector, data type, and then your vector name. In those little angular brackets, you want to put the data type. So for example, you'd say like vector of int, vector int in bracket, and those angular brackets, and then 80. And so you'll see that you don't know how many elements are going to be in there. You don't know what they are, but it still has that ready for you, which is nice. And to declare a vector in C++, you can also use the following syntax. So you could still do the stuff you can do with arrays. You can declare it with a size and with additional value of elements. So for example, you could say you want an array filled with hundreds, dollar bills, I don't know. And so you could do that using the syntax, a vector of ints called hundreds by 100. Okay, yeah. And then a lot of array syntax works for vectors as well, which makes them really useful. So it allows you, so here, vector with the square brackets equals true. That allows you to access the element with index 2 and modify it. So here in this little array, we modified it, which is nice. In this way, you can use vectors very similarly to how you use arrays. However, vectors also have a lot of useful functions that are associated with them that you can use to make your life easier. You'll probably learn more about these later, but some like common functions we could use or bits of code that will help you out with when you're using vectors. There'll be these ones right here. I'll just go through them briefly. Vector, you could say, if you put after the name of your vector, dot size with parentheses, it'll give you the size of the vector or how many elements are in it. Front returns the value of the element at the front. Back returns the value of the element at the back. And empty will tell you if it's empty or not. It's true if it's empty, false if it's not. Pushback allows you to put something into the back of the vector. Insert allows you to insert something wherever you want. It's kind of more useful than pushback. And then you can erase at different places. So I advise you to check this out yourself. And if you want to look up other ones, there are plenty more that can help you deal with vectors already. Great. So now we're going to move on to what is a string. A string is a data type that represents a string of characters. You can use it the same way that you use any data type in C++, like integers or booleans. And so to initialize a string in C++, you use the following syntax, like you just do generally in C++. String, which is the data type, the string name, and then wherever you want in your string. Or if you're going to be inputting that later, then you don't have to include whatever you want and just put the semicolon right there. Awesome. So strings are also similar to arrays in that you can access and modify them element-wise using that syntax right there. So the name of your string, and again, the element that you want to access and modify. And so some common things that you can do with strings will be the following. The name of your string, you put like dot size, then it'll tell you how many characters are in it. Same with dot length, it does the exact same thing, which is cool. You can push back with like the vectors. You can also concatenate strings, so you can add them and you can get, they'll be like one after the other. And then you could use these right here, like is on them, will tell you if it's alphanumeric. So if the character that you put in the brackets is a number or a letter, and use something like to upper, which will, if you put a character in the brackets, it'll put it to uppercase. And if it's not a letter, then it won't be. there are tons of, like, this is just like a short form list of things you could do with this. And I'm going over it quickly because, again, I don't believe you'll need these today. But it's interesting and it's really cool. You can do a lot with strings. Okay, yay. Cool. So what's important to know is that every character has a corresponding ASCII code. As shown in this table, I highlighted like the columns that you'll need to know about. So to find the ASCII code of a character in decimal, you simply find the character in the character column and find its corresponding row in the decimal column. So for example, you'll see that the capital R has the ASCII code 82, right? This is the capital R in the character column and then 82 in the decimal column. And a lowercase r has the ASCII code 105. The ASCII is very useful because it allows us to easily convert between characters and integers. Now, I know I personally found this confusing when I learned it, I just want to do a quick quiz. If anyone wants to answer, what is the ASCII value of the lowercase v? Yes. Yay. Thank you so much. That's incredible. Okay, awesome. And then what is the ASCII value of 7? Ooh, yes. 55. What did you say? 55? Awesome, yes. You're correct. Thanks, you guys. You really helped me out. Okay. So you can notice how the value, I just put this in here too, because I want you to notice how the value of the number and the ASCII value is not the same thing. I don't know. That confused me a while when I first learned it, so I thought it was important to mention. Okay, cool. So how do we use characters? A lot of people, myself included, don't really like strings problems sometimes because the syntax can get really annoying. And so if you're new to dealing with strings and characters, the syntax, here's what you need to know about it. So first of all, double quotes are for strings and single quotes are for characters. So for example, if you have like, here, A in double quotes, that is a string and C++ will treat it as such. Or if you have it in single quotes, it's a character. Great. And what can characters do that strings cannot? Well, one thing is that characters convert automatically to their ASCII value, like when you need them to. So here we have like code, for example, here. Oh, thank you so much. This string, this is just ICPC. And then if you want to see out like the string at the first character, it'll give you I, which makes sense. But if you give out like the first character plus 1, then it will automatically take that string and convert it to its ASCII value and add 1, which is weird and great because, as we learned or reviewed, arrays are accessed via indexes that are numbers. So it's very useful for dealing with arrays because the elements are indexed by integers. So you can index into an array directly with a character. So for example, if you wanted to put like, if you have this array, and then you put like this character here, it'll automatically index into the 99th position, which is cool. But C is the 3rd letter of the alphabet, and we probably don't want to reference it like 99. So here's a quick tip to deal with that. If you put like a character, and then you subtract the first letter, for example here, C minus A, it will convert both of those into integers until I have 99 minus 97, which will be array at 2. In this way, we can access the information for C at the index C, which is much more practical. If that didn't make sense, talk to me after when we're doing problems that we'll deal with it, because it's just a quick tip, makes a lot more sense in practice. Okay. Thank you. Thank you for listening to that. That was kind of long. So now we're going to get to our first problem, Peragrams, and it deals with strings, which should be fun. So I'm going to have Alvin introduce this problem to you. This is the string problem. Oh, okay. I can do this as well.
We can
Just do it together.
guess, yeah.
Okay, we're gonna do this together. It should be fun. Awesome. So hopefully you're able to access this through the link that's on the slides. also should also be up there. Thank you. Yeah, I'm just gonna give you 30 seconds to access it and then read it. And after you read it, we'll go through the problem statement together.
Anyone still need the link?
Cool. Okay, cool. Hopefully you've had a chance to look over the problem statement. I guess it's a nice introductory problem, especially if you haven't worked with strings before, but if you have even, then maybe you'll be able to get it done in the like 5 minutes we will have for you to do it. All right, cool. So the problem statement, Per recently learned about palindromes, and now he wants to tell us about it, and also has more awesome scientific news to share with us. Actually, maybe I won't read this because I feel like you guys just read it. So cool. We're gonna work through the input and output. So the input consists of a string on a single line, and the string will contain at least 1 and at most 1,000 characters, and the string will only contain lowercase letters from A to Z. And the output will just be a single integer on a single line, which would be the minimum number of characters that have to be removed to make this a paragram, which is an anagram of a palindrome. Cool. And so we can see here in the first case, ABC, if you remove, say, B and C, then it'll just be A, which you can read it backwards and forwards, and it's the same thing. And if you don't move anything from here, but you move, it's A, B, A, then you can read that backwards and forwards, it's the same thing. It's a palindrome. And so this is an anagram of a palindrome. Does that make sense? All right, okay. If anyone has any questions, please ask it at any time. And I'm gonna give you 5 minutes, so until 6:32, to work on it. Yay, okay. It's 6:32. Hopefully you've had time to like look at it, think about a solution, maybe even code it up and submit it. Who knows? Okay, awesome. So we're gonna just, sorry if you're still working on it. I know that's not a lot of time, but we're just gonna walk through the solution really quick. Okay, yeah. So basically all letters that are present in an even amount can be kept. And if there are any letters present in an odd amount, then all but one of them needs to have one of their letters removed. So you basically just, it's the amount of letters with an odd frequency minus one, right? So in ABC, if you remove A and B, we leave C, makes it into a paragraph. And hopefully you can see, I guess, why that is the case. If it's even, then we can have it on either side. And if it's odd, then we can have it, we can't have it on either side, unless there's only one of them, in which case we can have one in the middle. And that would make it an anagram. Alrighty. Here's some code that does that. This is using arrays and not vectors, but also, yeah, I'm sure you could also come up with great code that will do this. It's a fun little problem. And we have another fun little problem coming up next. It's this is like dwarves in Croatian or something. So yeah, go to this link if you can and read through it, and then we will go through it, the test cases together. Okay, so hopefully you've had a chance to look at the problem statement. I'm not sure if that was enough time. I'm just gonna leave this up for another like 30 seconds, and then we'll get into it. Okay, yay, awesome. So I feel like this one and the last one were similarly simple to understand, I suppose. So I'm not sure if you really want me to go through it, but I'll just go through the first one. You see we have like 7 plus 8 plus 10 plus 13 plus 15. Where is it? 7 plus 8 plus 10 plus 13 plus 19 plus 20 plus 23. So up to 100. I can't prove it, but it really does. And the other two numbers, 15 and 25, do not sum up to 100 when combined with any of the other numbers. Hopefully that helps. I'm gonna give you, I guess, 10 minutes to read this over, try and solve it. If you have like any questions at all, any problems like coding it up or syntactically or anything like that, please ask. We'll be walking around. All right, okay. Hopefully that was enough time to like get started on it, perhaps code it up. If it wasn't, no problem. The time limit is not like the difficulty of the problem. It's purely based on the constraints of being in this classroom for a set amount of time. Okay, so we're just gonna go through the solution really quickly. Okay, so we know that two numbers in the array do not belong, and all the other numbers will sum to 100, and the two that don't belong will bring it to some value that's greater than 100. So we can take in the input, sum up the numbers using a single for loop, just like this. And then the two dwarfs that don't belong will have numbers that sum up to the total sum minus 100. And so our target is equal to the sum minus 100, which in this test case would be equal to 73. So then we need to only find the two numbers that sum up to our target. And the simplest way to do this, which wouldn't work in every case, but will work in this one because we have such small constraints, is to just try out every combination of the dwarfs, which we could do with two for loops. So hopefully you can see here, we have like 4 and times equals 0. So for every index, try it with every other index. And if their sum is equal to the target, then you print out every other dwarf. Okay, awesome. One comment on this is that the solution will be good enough to pass like this problem because the problem has such small constraints. There are only like 9 dwarfs. An error correct solution, we use brute force. What if there were like a million dwarves or like a billion dwarves? I don't know. At some point, going through every single dwarf and matching it up with every other one is going to cause problems for our computer. It will overheat or take forever. So is there a way to like do this, do you think, without using nested for loops? That is, time complexity in linear time. So or going to the array only once. A hint is what if this array were sorted? It would look like this. I'm just going to give you like 30 seconds to think about it. Oh, yes. Okay. Yay, all right. So hopefully you had a chance to think about it. So one way we could do this is we could keep track of these two indices and we can add the values at them, starting at the leftmost and then starting at the rightmost. Then we can add the two values at the indices. So if we can see that it needs to be smaller, we can decrease the rightmost index. And if it needs to be bigger, we can increase the leftmost index. And in this way, we can narrow in on our two dwarfs. This is overkill for this problem, but this technique is common with the race problem, so I wanted to mention it, like dealing with two indices, comparing them, and then doing something in regards to that with them. So it's known as a 2 pointers technique, or sometimes sliding window. And yes, awesome. So thank you for sticking with me. We have reached our final problem. If you've been bored thus far, this one jumps to a higher level of difficulty. If you haven't, this one will tickle your brain a bit. It will be fun. So hopefully you can access this on using the link and they'll read it. And this one, we're going to go over the test cases because it might be a little bit difficult to understand. I know it was for me the first time I read it. So I'll give you like a minute to open it and I guess a minute to read it. So 2 minutes. Thank you. Please, that's all right. Thanks for coming. Okay, awesome. Hopefully you've had a chance to read through that. If you haven't, don't worry, because we're about to go like through a test case and then you'll understand. Hooray. So sample test cases, we're gonna go through sample input number 1. So basically sample input, oh, I guess we're going through sample input number 3. Never mind. So here we have these balloons, right? And so basically the idea is that you shoot a balloon, and once you do, the arrow, I guess physics loses momentum and it drops down to the height that's h minus 1. So 1 that's lower, right lower than it. And then any balloons that's traveling along that it could hit along that path, the same thing will happen. Does that make sense? So you could do it with 4 arrows like this. For example, you could hit this water balloon first, and then you could hit 2, in which case the arrow will fall down 1 height unit and hit balloon number 5. All right, and then you could hit 1, in which case the arrow still falls down 1 height unit, but there are no balloons in height 3, and then you can hit balloon number 3. Alrighty, you can also do it with 3 arrows like this. You could hit 3 first, and you see when you hit 3, the arrow drops down a height unit, hits 4. Incredible. And then you can hit 2, which again drops down a height unit, hits 5, and then you can hit 1. Right? And so what this test case is saying is that 3 bullets, like the sample output is 3 arrows is optimal. So you can try the different combinations for yourself, but you'll find that you won't be able to do it with any less than 3 arrows. Or if this problem is correct, you should be able to find that. So see if you can figure out why that is and create an algorithm around that fact. This one, in my personal opinion, but I think generally, is quite a bit more difficult than the last 2. Requires more thought. So definitely, if you have questions or comments or concerns, we'll be around. Flag one of us over. Yeah, think about it though. It was fun. I'll give you 10 minutes. In 10 minutes, I'll check back in and we'll go through the solution. But if you have any questions in the meantime, think about it. Thank you. Alrighty, I guess it's been 10 minutes and we're gonna start reading at the contest time in a second. So unfortunately I have to stop you there. Hopefully you've gotten a chance again to think about this problem. Probably not code it, but if you have, that would be incredible. All right, we're gonna get started actually walking through it right now. So the optimal solution to this problem is just to hit the leftmost unpopped balloon. And alternately, you could hit the uppermost unpopped balloon. You think about, we're gonna understand. I'm gonna explain the first case and then the solution kind of applies to both of them. Right, and because the optimal solution is just to kind of do this degree solution. In case you need to know like what type of problem it is. Just know that you're learning today. This is great. All right, so we're gonna look at this test case again to see like why this is true. So first, there are two ways that an arrow could hit a balloon. Either we throw the arrow specifically at that balloon, or the arrow drops down from another balloon. Right, for the leftmost balloon, since there are no balloons before it, if it gets popped, it must always be because we threw an arrow at it specifically. Otherwise, like there's no way for us to pop it, and we have to pop it. So we're going to have to always throw an arrow at this balloon. And so intuitively, I suppose, if we have to throw an arrow at this balloon anyway, why not throw it first and then see what it hits? Okay. Similarly, we should know that it would never be optimal to shoot a lower balloon first, because there are two cases. You can either hit it from a higher balloon, in which case it'd be optimal, of course, to shoot the higher balloon first, or you can not hit it from the higher balloon, in which case the order that you hit them does not matter. Okay, great. So the final question to ask is it ever beneficial to pop a balloon to the right before popping the leftmost balloon? This is, of course, very important. So again, there are two cases. One, the balloon is higher than the leftmost balloon, and the arrows would not hit the same two balloons. So, for example, here, see balloon 2. So if you hit balloon 2, it'll fall down and hit balloon 5. And if you hit balloon 1, it will fall down and do nothing. But their paths do not cross at all. So it completely doesn't matter whether you hit balloon 1 or balloon 2 first, right? Or the balloon, we switch test cases here because this, I guess, makes it more clear. The balloon is higher than the leftmost balloon, and the arrows would hit the same balloons. That is, they're all sort of the same, right? Okay, so notice how shooting 1 would also, in this case, pop balloons 4 and 5, but shooting 2 would then pop balloons 3, 4, and 5. Either way, we can guarantee that all the balloons will be removed because as soon as we hit 4, 5 will necessarily be hit. Because the leftmost balloon is lower than the next one, we'll always need to use two, is leftmost than the next one, we'll always need to use 2 balloons to remove them. So again, the order does not matter. Great, so hopefully that was clear and we can see why you always need to hit the leftmost balloon first, or the leftmost unpopped balloon first, which is fine to notice. But now we have to actually code it. So really, in the case of this problem, there are, again, many ways to like code up a problem. And if you find one and you think that you can find another, that is great practice. You should definitely do that. But all we need to do to solve this problem is simulate that. So there are faster ways to do it. And you can use data structures that we haven't learned yet, but if you continue in competitive programming, you will, or perhaps you already know them and you don't need us to teach you. Right. And so here is code for this, which is just, you have an array for balloons and a Boolean to say whether or not it's been hit. And an integer to keep track of the amount of unpopped balloons. So you just go through and initialize that they all have not been hit yet to start, which is this first for loop right here. And then you take in all the balloons into the count to 0. So this is all, the whole left side here is just initialization. And the actual code here is on the right is doing the simulation that we need, which is while unpopped is greater than 0, we go through it And I is equal to 0. This. If you haven't hit it. Sorry, yes. And so we have our target, and if we haven't, if the current balloon if it's false that it's been hit, if it hasn't been hit yet, then we increase the count, and then we set hit, this balloon has then been hit. So then the amount of balloons that are unpopped decreases, and our target value becomes the value of the balloon that we just hit minus 1. So we see that we just hit this balloon, and then it's minus 1, right? And then for all following balloons, so we have J, which is equal to I. And if at that point, balloons at J is equal to target, so it's equal to the next lowest height, and we haven't hit it yet, then we say we've hit it, and we pop it, and we again decrease the target. So we just continue doing that. And in that fashion, we simulate it. Hopefully that makes sense. If it doesn't, and you have questions, please ask. All right. I suppose that's it. So there's definitely time to ask questions if you want to, because that is it. We have our feedback form where you can fill out what you thought. And if you have questions, I suppose you could also put them in there. Comments, concerns. Our contest will be starting momentarily. It's fun. I feel like I tried to choose the problems such that they're in between the difficulty of the two types of problems we covered today. Balloony being on the higher end, and the dwarves being on the lower end. So yeah, fill out the feedback form, and then that will be it. We'll have our contest link right here, and then you can start the contest. Check collecting new skills. Yes. Yes. But
Yeah,
yeah.
we're gonna adjust the time once we give you guys a little bit of time to